Consider a long solenoid of length L and radius R. If N is the number of turns per unit length and mu dot is the permeability of free space, the inductance of the solenoid is. एक solenoid इसकी length is L and radius R or number of turns per meter is N. इसका area of cross section A will be pi R square. Inductance will be mu dot N square A into L और mu dot N square A की वैल्यू pi R square into L और mu dot pi N square R square L. This B is correct option. Next, two identical inductors are connected in two different configuration P and Q, where a time varying IT is flowing as shown in the figure. The induced EMF A between A and B configuration P is EP and that of our configuration Q is EQ. The ratio of EP and EQ neglect effect of mutual inductance. Between A and B, suppose inductance of each inductor is L, 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 L. So, inductance between A and B between AB is equal to L. The magnitude of induced EMF will be L di by dt. EP is equal to L di by dt. The resultant inductance between A and B in Q configuration ये दोनों इंडक्टेंस आर इन पैरेलल, तो रिजल्टेंट अगर यहाँ पे हम एक रिजल्टेंट इंडक्टर लगा दें और इस रिजल्टेंट इंडक्टर की इंडक्टेंस इज L1, तो 1/L1 विल बी इक्वल टू 1/L प्लस 1/L 2/L और L1 इज L/2. तो AB जो EQ होगा, EQ विल बी जो मैग्नीट्यूड होगा इसका L1 di by dt or L by 2 di by dt. So, ratio EP by EQ L di by dt, L by 2 di by dt. This is 2. A is correct option. Next, a conducting loop of finite resistance lies in xy plane. There is a constant magnetic field in z direction. The area of loop varies with time t as a dot 1 plus sin t. Sin t in appropriate units. The figure that correctly indicates quantitative behavior of the power dissipated in the loop as a function of time is magnetic field is in z direction. A loop is placed in xy plane. इसका area is A is equal to A dot variable area with time. The flux is B into A or B A dot 1 plus sin t. Rate of change of flux d phi by dt is equal to B A dot 0 plus cos t is equal to B A dot cos t. Induced EMF is equal to minus d phi by dt or minus B A dot cos t. Power dissipated P, अगर resistance is R, epsilon square by R or minus B A dot cos t by square upon R or B square A dot square by R cos square t. This is always positive and initially when t is 0 it is maximum. Then C is correct option. Next, a rectangular wire of loop of side 8 centimeter into 3 centimeter with a small cut is moving out of region of uniform magnetic field of magnitude 0.3 Tesla directed normal to the plane of the loop. The EMF doubled across the cut if the velocity of loop is 2 centimeter in a direction normal to the shorter side of the loop will be dimensions of the loop are 8 into 10 to the power minus 2 meter into 3 into 10 to the power minus 2 meter. This is B and V is 2 into 10 to the power minus 2 meter per second. एक magnetic field and a loop is coming out. This is B and this is L. Suppose a x distance has come out and a small distance dx, this is dx, is moved in dx, distance moved, ये लेफ्ट टू राइट मूव कर रहा है, dx moved in small time dt. dt टाइम में जो फ्लक्स चेंज होगा that will be b into dx into capital B. This is phi. या इसको हम d phi लिख दें. Rate of change of flux d phi by dt, dt से डिवाइड कर दिया हमने, b into b into dx by dt, and this dx by dt is v, velocity, the speed of this loop. d phi by dt is e, इसका माइनस is d phi by dt. Induced EMF through the cut, अगर यहाँ पर एक कट लगा दें, माइनस b is 0.3 and small b is इसकी width 3 into 10 to the power minus 2, 3 into 10 to the power minus 2, and v velocity is 2 into 10 to the power minus 2 meter per second. .8 into 10 to the power minus 4 volt. .8 into 10 to the power minus 4 volt. A is correct option.